Hello, 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 hello.
Good morning, everyone. How you guys are doing?
We are good. Good morning.
Yeah, so it's a cloudy day today, right?
Yeah, I haven't been outside actually, so I don't know
You
how
don't
you.
have any window even?
No, I'm in my basement, so I haven't gone out.
Okay, that's why. Yeah, it's kind of bad weather today if you compare to like last 5 days. Like every day was kind of, very sunny, but today is really cloudy.
Yeah, it's
And
cloudy, but it's +1, so it's not gonna be a bad weather.
yeah, but the thing is that even if it's +1, you cannot go outside that much. That's the main thing, right?
Hmm.
Yeah. So far we just got a new case in Manitoba. So far it's 21 now. Yes. So
Bye.
I will request everyone so that you can do self-isolation. That means like without necessary, you shouldn't go outside, meet any friend, or any kind of social gathering is forbidden right now. Even if you go outside for grocery, like maybe superstore or anywhere, I suggest you to wear gloves. That will be helpful. And then just throw it out before you enter to your home. Yeah, trash it.
All
So
right.
in that way, if you even touch the cart of the superstore or any grocery store, you will be kind of safe if you don't touch it on your body. Yeah. So
God will
it's
save us.
very that the world, so it's very crucial right now. So this is the current update. Okay. So Chima, you can look at my screen, right? Like
Yes, I
everything
can
is
see your
okay,
screen.
and you can hear me.
Yep.
Okay. Okay.
Yeah, perfect.
So you can see that the condition of Spain goes very like over like
Oh my.
1,000 deaths right now. New deaths is kind of 500. So it was China at first. Then Italy is very like 6,000 deaths. Then the
It's
condition, yeah,
it's like Italy has gotten their own under control because
yeah,
there's
it's
no death in.
kind of it's kind of a pause right now. But Spain is increasing. USA is very bad situation. Canada overall, it's good. But if you look at Ontario or uh, hmm, like if we look at British Columbia or Alberta or Ontario or Quebec, like it's increasing very rapidly.
Yeah. Oh
Total number
my.
of cases in 2024. So I'm just showing you these things because you will be aware of this COVID virus. Okay, so we cannot guarantee anything. Maybe if you go outside in the air, there can be some virus you cannot see, right? And it will touch your body, then it will be spread. Yeah.
Yeah.
So are we all ready to play our game for exception handling?
Sure. We can try.
Yeah, so far I can see only 10 participants. Should I wait a bit? So do you have any question regarding your assignment or lab? I think the lab was kind of easy for this week, right? And I'm appreciating your questions in the discussion forum, but I will advise you don't to post any code, Chima, okay?
Code. Yeah.
Yeah, so it's not standard things because if
Yeah.
you post any code, you know that it's a violation of the plagiarism thing. So anyone else can get the idea or just copy your code. So I will request everyone to not to post any code in the discussion forum. Rather than you can use algorithm, you can describe the things. Okay.
Yeah.
So yeah.
So any update regarding our final exam?
It will be online for sure.
Oh
Yeah.
my, which means it's gonna be multiple choice question.
So still it's not decided. Maybe it can be open book exam also. Okay. The
Pardon me?
question it can be open book exam also.
Oh.
Like so there is no way we can monitor you, right? Because you know that maybe I can monitor via Zoom. Like what I can do, I can request you to give the video, but it still is like not appropriate. May so it still is not finalized how it will be, but for sure it will be online. It could be a open book, so question will be kind of more challenging if it is open book, you know that, right? Yeah, so I will let you know, guys, for sure.
I think if I am, well, I don't have any power for suggestion, but if I am to suggest, why don't you guys
Yeah,
make it like assignment stuff and then give it like we have
but
3 hours to submit the job?
but the assignment is already you are having like 4 assignments, right?
That's what
So
I'm saying.
final is kind of different. So we're trying to still, like, whatever the course is designed in the ROAS, we're trying to follow that one, because once a ROAS is uh, we are given the ROAS to you guys, right? See, it's written there how it will be. So we are trying to follow that one as close as we can do with that ROAS things. Okay. So anyway, we can see you, Chima. So it's nice to see you anyway.
Really?
Yeah. So it was not on
Now I'm go.
purpose anyway.
Now I'm gone.
Only 10 participants so far. Anyway, I think we are kind of 5 minutes delay, like it's 11:34. So we are going to start soon. So I will request everyone to join.
Sorry, I wanted to ask, will our exam be the same date as scheduled or not?
Yeah, still now it's the same date as is scheduled.
Thank you.
Yeah, no problem. So again, you need to go to kahoot.it. You can use
Oh
your
no, we don't
cell
want
phone.
coronavirus here. Who is the coronavirus, please?
Yeah, don't
We don't
spread.
want you in this
Yeah,
platform.
here.
Oh my. Coronavirus. It must be dangerous.
So 7 players, I would expect it should be 10 because so far we have 10 participants. Okay, yeah, so I'm also the participant, so it should be 9 actually. Let's start, guys, right?
Sure.
But why only 10? Is it for the cloudy weather? Your friends are sleeping? Anyway, let's start. So the very first question is a true or false question. There are 3 kind of exceptions in general.
Oh, we can't see the stuff.
Sorry?
Which one is true, which one is false?
You shouldn't, like tell anything about the answers. Or also you have a chat box, I think.
My screen can't display which one to
Yeah,
click
so for
true or
sure
false.
it's false, right? Because we have 2 kind of exceptions, right? What are those? One is checked and there is unchecked, right? Okay. So the winner is Shelby, and then the next one is which kind of exception indicates a logic error in the program?
Excuse me, I can't see the choices here.
Oh, sorry.
On my screen.
Yeah. So is it okay now?
No, I can't see it.
You cannot
here.
see it. It should be okay now. What about the others? Yeah,
I
for
only
sure.
I
For
only
sure.
see one choice to make here on the screen.
It's not the full screen, but why didn't you see it anyway? Okay, I think you should see it now, right? Can you see it
Yeah.
now? All the options?
Yes. Yes,
Okay.
I can see other options
Yeah,
now.
so for
Yeah.
sure it should be unchecked one, right? So anything that goes like the logical error or you know that regarding how the programmers doing the program or doing some error, it's all about the unchecked exceptions. Okay. So the winner is again Shelby, and the next question is, which one of the following is an example of the checked exceptions? Is it okay, Chima?
Still not.
It's still not?
You can go up. If you go
Now?
up, then I see. Yes, now is good. Yeah, it's good now.
Okay, yeah, for sure it's a IO exception, because you know that the runtime exception, the null pointer exception, and the array index out of bound exception, all of these exceptions are actually unchecked one, right? Okay, so the checked one is actually whenever you have the file related kind of exception or IO exception, those goes all about the checked exception. Okay, clear? So the winner is again Shelby. Oh no, it's Tyler one. So the next question is how you can handle an exceptions. Yeah, for sure both. Okay. Try catch is also an answer, but you know that you can also use throw to handle an exception. So the most appropriate answer will be both. Okay. The Tyler one is also the winner, and the very last question is the final statement. Let's see, execute code after type catch block regardless of the result. For sure, it's true. The finally statement actually is not related to the try catch. Whenever you will put the finally one, whether the catch is executed or not, the finally whatever you have written there, it will be executed for sure. Okay, so it's true. So the winner is, we have you can call me AI is the second runner-up, Shelby is the first runner-up, and the winner is maybe Tyler one. Yes, okay, we got the winner. So let's get back to our today's slide. Just a moment. So today we're going to learn recursion, right? So does anyone know like what is recursion?
Like a loop? I mean, it resembles it.
I will not take this answer. You cannot say loop here. There is no loop in recursion. No.
Recursion is a method calling itself.
Perfect. Yeah, that's the answer I want to hear. So whenever you call, it's like if you have a method and that method calling it itself, then we call it recursion, right? Okay, so let's start. So that's the very first line is the definition, that is a recursion applies to method and to data structure. Okay, it's not the definition actually, like what kind of recursion we have right now. Like there are two kind of recursion. One is applied to the method and that is the data structure. So whatever the definition Chima said, that's actually the definition of a recursive method. So we'll see how a data structure can also be recursive. Okay, so So the recursive method is a method that directly or indirectly calls itself. Okay, so that's the thing we just discussed. What about the recursive data structure? The recursive data structure is a structuring of classes so an instance can have a reference to another instance of the same class. So suppose I can give you one example. Suppose if we have an employee class, you know that in an industry, one can be supervisor, another can be, maybe one can be senior developer, another can be junior developer, right? So the senior developer supervises the junior developer. In other way, we can say that the junior developer, the boss of the junior developer is a senior developer, right? So there are two kind of different types, right? Like one is boss and there is the, like under the boss, there is someone working. But in overall, like the both of the kind is kind of an employee class, right? They are both actually employee of the company, right? So you know that this class actually, if you draw a line, you can draw a line itself, right? Like the employee class, you can draw a line to itself, right? Because in employee we have the senior developer, we also have the junior developer, right? And in the line you can say that supervise employee, right? So those kind of things actually we are calling recursive data structure. Okay, so we'll see example later. So let us first begin with recursive methods. What is that, right? So whenever we have a problem, right, the main motivation of the recursion is that rather than writing the same line again and again, can we just call the same function to do it works? And you know that whenever we call the same function, there can be possibility of like you can assume that it can be goes into infinitive time of calling that function, right? So if you don't give any kind of breakpoint, a function can call itself like infinitive time, right? So there should be some kind of base case. We call it base case. So what is a base case? Base case is something like where you are going to stop. Okay, so that's kind of a stop criteria. Like this is the end. We are going to stop here. That's called a base case. Okay, so just read the slide. Reading the slide breaks a problem into smaller problems of the same problem type, such that their solutions can be combined to form a solution. Okay, and the decomposition into smaller problems must be constructed in such a way as to terminate in a finite number of steps and to end in a basic form that has a known solution. Okay, so that's the thing I already told you. Now let me give you one example. So suppose we all know that how factorial works, right? So if 0 factorial, it's 1, 1 factorial, it's 1, 2 factorial, you can say 2 into 1 factorial, right? For 3 factorial, it's 3 into 2 into 1, right? So if you look at how it is calculated, you can see that whenever we are calling the 3 factorial, basically what you can do, you can just multiply 3 into 2 factorial, right? Again, for 2 factorial, you can multiply 2 into 1 factorial, just like that. Again, for 1 factorial, you can say 1 into 0 factorial. It's the same thing, right? So the very first line, that is 0 factorial equal to 1. So that should be our base case if we call this factorial as a recursion, okay? Or we if we design a recursive method of the factorials, okay? And then whatever, if it is not 0, what will happen? It will just call that number multiply into the same method with just -1. Okay, so if it is n is 0, we already know that the answer is 1. That is the base case. Okay, and then if it is n greater than 0, we know that we can do n multiply into n minus 1 factorial. Clear? Is there any question so far?
Oh.
Okay, so what we're going to do here, we can just write a code like that. Okay, so in this code we have an argument integer n, right, a parameter, right? So we are saying that if n equal to 0, we just returning 1. So that's our base case, right? And then whenever in the next line we can just say return n multiply into factorial. So the name of this method is factorial, right? Or this function is name is factorial. So we are calling the same function, right? So we are saying n multiply into factorial, and we are like in the parameter we are passing n minus 1. That is how it designed. If we look at the factorial problem, right? Okay, so what we are doing basically, we have a base case so that it will stop, and we are kind of breaking our main problem into a smaller problem. Why we are saying smaller problem? Because if you say factorial 3, right, then in the next iteration actually you are calling factorial 2, right? Because in you are calling the same function using a lesser value, because factorial 2, right? Okay, so that's why we're breaking into a smaller problem here. Okay, is it clear, everyone?
Yep.
Okay.
Yep.
So so we know that whenever we are calling a function, okay, so there can be like multiple times calling the same function, right? Suppose if I pass 3 as n, right, how many times it will be called? Can anyone say that? Suppose I am passing 3, then how many times this function will be called?
If you pass 3, we call I think more than 3 times.
More than 3 times?
Where do you want to pass 3?
Yeah, I'm just calling like factorial and then 3 as a parameter. Then inside this function, you know that again the function calling itself, right? How many more times this function will be called?
We call 3 times.
4 times?
Actually 3 times, because you know that using like factorial 2, it will be called at first, right? Then factorial 1, it will be called, right? Then it will be called with factorial 0, right? So whenever the value of n is 0, then it will start returning, right? Okay, is it clear? Like whoever says 4 times, is it clear? It will be 3 times, because with 2 factorial, then 1 factorial, then 0 factorial. Okay, so so then this is a call step slide. I will come back later. Okay, so I will just maybe I will just give this one at first. Suppose if you call like with 4, how it's working. Okay, so you can see that we are calling with this function with the parameter 4, right? Then it will go to the next one using, at first the very first one is using 4, right? So don't look at the right side right now. So this side don't look at, just follow my arrow. So this is the first one. You are calling the function with the factorial function with the parameter 4, right? So you know that inside the function you have another calling with 3. So that is that, right? Again you are calling with 2, right? Again you are calling 1, and this is your last call because we have 0 now, right? Okay, So whenever you have this 0, since our n is 0, now come to this right hand part. Okay, it's return 1. So whenever you have 1, you know that, like, this is the like understanding of how recursion working. Okay, so those who are not have a very good picture in your mind, like how this recursion is working, I'm not sure. I'm just writing a single line and it worked. How? So this is how it's working actually. Whenever, so this is like calling, right? And then it is starting returning. So when whatever you have this base case, it will start returning from there. Okay, so whoever is called that base case, it will return the value to that function. So it will returning 1 there. So you know that whenever you called there, you said that 1 into factorial 0, right? So 1 into, so since it's returning 1, 1 into 1 is 1. So then again, whoever is called that factorial 1 is so that returning things is already done. So it's returning 1 to the parent calling, like whoever called that factorial 1. Okay, so now in that function we have 2 into factorial 1. So now we know that factorial 1 value is 1. So it's multiply, so the result is 2, right? Again, factorial 3 call this factorial 2, and we already know what's the value of factorial 2. So it's returning also whoever called that function. Okay, so now in factorial 3 we have 3 into factorial 2. So now we already got the answer for factorial 2, right? So it will multiply and get the answer. In the same way, whenever we have the main calling things, okay, factorial 4. Okay, so we know that whenever we call, we say 4 that n into factorial n minus 1. So we know that factorial 3 is now value 6. So it will multiply and the final answer will be 24. So this is how the factorial, like the recursion things is working. Okay, so is anyone of you has problem of understanding how recursion work? Anyone of you have any problem how recursion works? Okay, so then we will see that how this tracing things working, like we call it call stack. Okay, so to control the execution of these several methods, who is just calling itself, the Java virtual machine uses a memory structure called the call stack. Now who can say me what is a stack? Anyone? Is there anyone who can remember what is a stack? No one can remember what is stack. What is QE? What is the difference between QE and stack?
But we didn't cover Q and stack.
Sorry?
We didn't cover it in programming.
Okay, so you didn't
but
take, okay.
Like in a queue, you know, like in a line, when people are in a line, it's just like a queue, like there are some datas. It's like a sort of array, but you can delete data from it comes from one side, but you delete it from the other side. I don't know how to explain it.
So
and in stack you can put it like I don't know how, like in a stack you put it and then the last comes out the first. Like if you want to delete data,
we got the answer. Yeah, you are perfectly correct.
It's just hard to explain it without pictures.
It's correct, like whatever you said, it's correct. So there are two keywords actually regarding stack and QE. Okay, so whenever stack, you can remember the keyword called LIFO, LIFO. So that means that last in, first out. And whenever you have QE, you can remember FIFO. That means first in, first out. So for QE, you can remember like the QE of a bus stop. Whoever comes first, he is get on the bus first, right? This is called the QE. But stack is just the opposite. Whoever come last, he will get first. I can give you example like you know that if you have a table and you have like 10 plates, right? So whenever you are just pile up those plates, you know that the very first plate you put on the table, right? Okay, so suppose you just like one after one, you just organize those plates, okay, one like above another, okay. So you know that the 10th plate you put it very last, but whenever someone comes to you know, for a buffet dinner or anything, comes to get a plate, you know that the first plate it take out first, the last plate, sorry, right? And the very first one, whatever it touches the table, that's the last one to get out, something like that. Is the example clear, everyone?
Yep.
Okay, so yeah, so
Sorry, will we need to know this like for a final exam?
no, it's just like for concept of this recursion, because
Oh, okay.
we are saying call stack, so you will not get the idea of stack whenever you know that, like whenever we're discussing like how this is execution is working inside the memory. Okay, so that's why I'm just explaining. Okay, if you take any course like data structure, it will be more clear there. Okay, I'm just giving you some hints so that you can realize like what we are going to do with the call stack in regards of the recursion. Okay, clear? Okay, so now you already know what is a stack. Okay, so when method A calls method B, the Java virtual machine ensures the field values of method A are in the edge area of the stack. So you know that if I call like the factorial 3, whatever the values or operation regarding that factorial 3, it will be at the very low of the stack. Okay, then factorial 2 will be upper of that factorial 3, then factorial 1 will be upper of that, something like that. So we'll have a figure, I will explain soon. Okay, the location is method A, to which control will return, allocates a new area on top. That's why we are saying stack. Okay, for the newly called method B. Okay, clear? So now, so suppose I have a method A. In method A, I have a variable called X, and it's calling another method. Okay, so now since I have a method B, okay, that is inside my method A, you know that here method A, so this is kind of a stack. Okay, so method A will be at the bottom, then method B will be top of that method A. Clear? So whenever this method B will be top of method A, whenever method B execution is finished, right? So it will be popped up. That means it will be vanished from there. Okay. So it's returning, right? And returning, and we have the value called 5. Okay. And then you know that this upper portion is now removed. So this is how stack is working. Okay, so if you compare just this one as like the plate, you have like 2 plates here, you have 1 plate now. Okay, just like that. So now the same example I gave you, suppose for factorial 3, how these things are working, right? So inside your main method, you are calling a factorial method, right? So that's why main method is at the very bottom, and then the factorial 3, whatever the method you are calling, that is top of the main method. Then we know that whenever we are calling factorial 3, it will call factorial 2, right? So that's why on top of factorial 3 in the call stack, we have this factorial 2 things, right? So this factorial 2 again calling factorial 1, right? Okay, so in the book or also in the slide there is a typo actually, so it should call factorial 0 at last. That's our base case. Okay, so anyway, so also you can think that we can change here. So you can see the very first two line, there is no kind of such operation. We can also change our definition of the base case. We can say, right, if n equal to 0 or 1, like we have to say n equal to 0 or n equal to 1, return 1, right? So this is just an extra operation we're doing. If we just put the base case like that, you know that we're just like adding one extra operation. So these two can go also in the base case. It's the same thing actually. Clear? Any questions so far? So that's why we can also write like this. Whenever we're calling factorial 1, that's the kind of n things, because 1 into 1 is always 1, even if you call factorial 0. Okay. So it will then try, like it will then start returning, right? Because this is the base case, right? So whenever you reach the base case, then it will start return, right? So it will return to the previous one, return 1. So this factorial 2 will return 2 then, right? Then this factorial 3 will return 6, and we are going to main. So this is kind of a stack thing, call stack things. Whenever a new method is called, it will be piled up. Okay, whenever we're done with that method, it will be popped. Okay, clear? Any questions so far? Okay, so this slide we already covered. So now this is another example of how we can or which of the cases we can use recursion. Okay, so you need to pick those cases where you can have other solution, but maybe you can do some kind of optimization maybe. So suppose an array is given, right? So how we can do the sum of this array? We can just create a loop, right? And just adding each of the element, right? So rather than doing that, also we can use a recursive function, right? How? The base case, there is no particular base case here, right? It's just adding the elements of an array, right? So that's why we're just saying that if the like the index is 0, or not index even, if the number is 0, return 0. Otherwise, calling the same function, okay, just we are using this format, like data n minus 1, that's the actual value, and then it will call again with the previous one. Okay, so let me give you an example where it will be more clear. Suppose you're calling with the same function. Okay, so data is an array, so the array means like the whole array is given, this whole array is given, and then you are just saying that I want the first 5 or 6 element. So if you give index 5, actually it will return 5 means, yeah, 5 means I think the first 5th element. Okay, so what it will do, it will call, so again, let's not look at the right side, let's look at the left side how it's working. So it will call function with the array index 5, then same thing, it will just decreasing, right? Decreasing, right? Decreasing. Then whenever it will return, you know that it's returning. So the very base case we have return 0, right? Okay. Then in the next case, we got like the 0 and plus data 0, right? So if it is like this, okay, then what is happening? We have 4 in this first index, right? Okay, so it's returning to the previous one. So 4 plus, actually it will work as data 1, that is 3. So it will just add them up, it will return. Then with that, it's just adding with the third index, okay, then with the fourth index, and then with the fifth index. So it's just working like this. So what I said to you is that, like, whenever you are using the recursion, you have to be just careful. Any question? Chima, your sound is not clear. Can you ask me again? Do you have any question, anyone? Okay, so we can continue. So it is working like this, right? So maybe, so what I want to say here is that, so this is a very small problem, right? So it's just like adding the elements of an array. So for this, you can use a for loop event, you can use a recursion event. So it will not make you any difference. Maybe you are getting the result at the same time. But whenever you have like the very large problem, you know that rather than using a for loop, maybe the recursion will give you the better runtime. Okay, clear? Any questions so far? So that is why, like, rather than using a for loop, we can also use recursion. Okay, clear? So now I will give you another example of the Fibonacci number. So we all know what is a Fibonacci number, right? So the very first two numbers are fixed here. The very first one is 0 in this series, and the second one is 1. And then after that, any number is the summation of previous two numbers. Okay, so that's why the series is, the very first one is 0, like I said, then the second one is 1. These two numbers are fixed. Then the next one will be the summation of previous two. The third one is 1 because 0 plus 1 is 1. The fourth one is 2 because the previous two numbers, 1 plus 1 is 2. Then 3 because 2 plus 1 is 3. Then 5 because 3 plus 2 is 5. Okay, clear? So who can say what should be the base case here? Is there anyone who can say me what should be the base case for this problem? No one? We guys can chat even, right? So are you guys listening to me? Is there anyone who can give an example what should be the base case of this problem of Fibonacci numbers? Anyway, let me give you the solution. Is that the very first two numbers, right? Okay, so one is we have the very first one is 0, and then the second one is 1. So we have two base cases here, right? And then we can call the main function. So here, the very first two numbers, one is if n equal to 0, we can return 0. Another is if we have if we have n equal to 1, then we can return 1, right? So those are the two base cases for here. Okay, any questions so far? and then we can just call Fibonacci n-1 plus Fibonacci n-2. So we are dividing the problem more here, like we have two simpler problems now. So the previous examples we just saw that we have one single smaller problem. So now we are breaking down into two, like we are calling it twice rather than just a single time. Okay, and we have two base cases here. One is n equal to 0, return 0, n equal to 1, return 1. Clear? So there is a problem here. Okay, so what kind of problem we are facing here is that we are kind of performing the same operation again and again. How? Look at this tree. Suppose we are calling Fibonacci 4, right? Okay. So whenever you are calling Fibonacci 4, actually it will call Fibonacci 3 and 2, right? According to this description of the solution, right? Okay. Then whenever we are calculating Fibonacci 3, we are calling Fibonacci 2 and 1, right? So again, Fibonacci 2, 1 and 0, these are the base case, so it will stop here. So if 1 is a base case, stop here. If 1 is a base case, stop here. If 0 is a base case, stop here, right? So now, if you look at the whole tree, right? So you have calculating the same thing like F1 3 times, right? Calculating the same F2 2 times, right? So this is kind of, you are doing the same thing again and again, right? So is there any way we can optimize it? Anyone? I just sent you one message. Are you guys getting it? Or you can just reply in the message also. So okay, so yeah, okay, you can see it anyway. So now how we can optimize it? Do you have any kind of suggestion to me? Or otherwise I will just start, like I will just explain how we can do it. So how we can optimize it? So one thing we can do that whenever we have a factorial 2, we can just put it, so it actually depends upon the problem. Okay, so for this one only, what we can do, whenever we have a factorial 2, we can just have a separate method for that. We can just call that method, right? So that the execution will not do again and again. The same execution will not do again and again. So this can be one way, right? So there can be many other way, maybe complex ways. So we are not dealing with those one. So for now, this is so far what you need to know is that recursion can also has some kind of disadvantage like this, and there are some also way to overcome that. Okay, clear? Any questions so far? Now we'll move to the recursive data structure. So do you have any question about recursive method? So I told you at the beginning of the class we have two kind of recursion kind of. One is recursive method, and this is recursive data structure. Okay, so what is recursive data structures? Classes have associations with other classes. If an association involves the same class more than once, we say the association is recursive. Okay, so we can give example like a team plays against another team, right? Okay, so it's the same class, we are redirecting itself. That's why we are saying this is recursive data structure. So you know that person class, right? So in person class, there can be child and there can be parent, but both are actually a person, right? So father can guide to child, but it's the same class. That's why it's a recursive data structure. Like I said before at the beginning of the class, an employee reports to another employee, maybe junior and senior things, right? Okay. So now let me give you as an UML diagram, like how it works. So by these UML things, you can understand more, right? So suppose I have an employee class, right? So maybe a junior employee reports to a senior employee, right? So we call supervisor, right? So that's why like we drag a line and says reports to the same class, and we say that this is supervisor. Okay. So this is how an employee reports to another employee. Okay. So this is called the recursive data structure. Okay. So this association can be in two ways, like an employee reports to another employee, right? Another way can be an employee may supervise many other employees, right? Okay. So there are two kind of association here, right? So can you name it this kind of association? Like one is one to one, right? So if you think like a junior software developer, he has just one single manager, right? So he reports to his supervisor only. It's like one to one, right? But in the reverse direction, a supervisor guides many employees, right? So it's one to many, right? Is it clear? So whenever you are saying number one, it's one to one, right? Relationship. And whenever you are thinking about number two, it's one to many, right? An employee may serve many other employees, right? So let's see one example of the very first one, like an employee reports to another employee. Okay. So what we're doing here, okay. So we have a class called employee, right? So in this class, actually we have another, we have the same instance of this class. That is, in employee class, we say that private and the type is employee and we name it supervisor. That's why we are saying this is recursive data structure. Because inside this class, we are having the instance of the same class. That is why. Clear? And now we have the first name, last name, and no argument constructor like this. Okay. And then maybe you can have a constructor with like the first name, last name, and supervisor things. And then we have the getter and setter. So most important getter and setter here, like regarding to this problem or regarding to this recursive data structure, is that we have a method called get supervisor. It's just returning the supervisor, right? And we have a method called set supervisor. We are just setting the supervisor, and you know that this is inside the employee class and it's taking a parameter of the employee class. So that is why we are saying this is recursive. Is it clear? So this is kind of an example how we are designing. Okay. So what happened to you, the great king Nania now? Anyway, so this John, okay, this is an employee. The supervisor of the John is Peter. Okay, again the Peter has a supervisor called Susan, and Susan has the supervisor Tom, and Tom has the supervisor April. Okay, then what we are going to do is that we are setting like this. So each of them, like the John, Peter, Susan, Tom, April, all of them are the instance of the same class called employee, right? instance of the same class called employee, right? And then we have a method called set supervisor. So what we're doing here, object name dot method, and we are just setting the supervisor like this. Here, any questions so far? Okay, so then what we are doing to display the name of the someone supervisor, what we can do, we can just say that you know that this is the instance of the employee, and then we are calling dot get supervisor. So that is how we are actually getting an instance of the employee class, and it's a super, like this is another object, right? Another object, and we are having an employee instance. So that instance actually we can access each of the method, like get first name, get last name, right? And this way the recursive data structure actually working. Is it clear? Is there anyone has any question regarding this example or the data structure? Any question so far? You are okay. Yeah. So this is actually the very last slide of today's class. This recursion is a kind of a short topic. So what we will do in the next class, we will go for some example of the recursion. Okay. So maybe I will give you some very simple problem. Okay. And I will ask you, or we can do it together in the next class. Okay. Or if you have any kind of problem with understanding a particular recursion problem, we can also discuss with that. Okay, so in the exercise we have like different kind of problems regarding the recursion. Okay, so we can also go for those problems in the next class. So any questions so far?
We're gonna be expecting a lab this week.
Yes.
Okay. And you're gonna upload the final assignment this week too.
Yes.
Perfect. Okay.
Yeah. So my office hour is up to 1:30 today. So if you have any question, you can also email me. If you need, we can come to the Zoom like one-to-one meeting. That is also possible in the office hour. Does anyone have any question regarding the recursion things?
I think we are good.
You're good. So you got disconnected, maybe?
Yeah, my microphone, my computer microphone was having some issues, so I switched to my mobile phone.
Okay. Anyway, no problem. So now, if you have anyone have any question, you can ask me even regarding anything. So I got your message later, like Sarah asked, like, are there any updates regarding the final exam? Actually, we already discussed about that one, right? So do you have any further questions, Sarah? Or you got your answer? You can also chat if you want. So I'm again repeating regarding the final exam. It will be online for sure because it's April 15th, right? And the situation will not be okay. Maybe it will take the whole summer. Who knows? We cannot, like the vaccine of this virus, it will take like 1 year or 1.5 years for sure. So there is no way we can have the exam like in person or inside a classroom. It should be online for sure. And the thing is that for online, it may be really tough if we monitor each one of your video like separately. It not make sense. So maybe it could be open book, or it can be closed book, but it's still not decided. I will let you know. If it is open book, the questions will be a little bit challenging, you know, because it's open book. Yeah. So that's the thing. I don't know if it is just me, but are the lab 9 marks appeared, because I haven't got mine. So what about the others? Sarah asked a question like,
I haven't seen my lab 9 too, so I don't think it's only her.
Okay, then what I'll do, I will email the TAs. Okay, so for lab 9, yeah, the deadline was Saturday, right?
Yep.
Oh no, so this week was lab 10, the last week was lab 10 or lab 9?
Last week was lab 10.
Lab 10, so lab 9 should be there. So I will ask the TAs to upload the mark for sure, because it was the last week. Yes, yeah.
Sure.
Yeah, thank you. Any other concern?
I don't think there's any other concern about.
Then
the
we can.
Concern there.
Yes.
The concern there will be is, since you said is you don't know if it is gonna be open book. If it's gonna be open book, it will be on the topics we have covered, right? It's not gonna be outside of the topics we have covered.
No, for sure. Why you are thinking that? Whatever we have covered, that's your whatever, you know, that we are following a book here, right? So this book is our syllabus, and you know that we are just following each of the chapter one by one, right?
Okay, sure.
So we just cover chapter 9, and chapter 10 is the very last chapter. So that is your very last topic.
Okay. So the exam, if it is open book, the questions will surely come from those areas, but
for
it
sure.
will not be something. That's what I want to confirm, and that's what I want to
for
know.
sure. Whatever you are learning in this course, you know, the topics are kind of already decided for each of the slide name, or you know that what is the topic there, right? So suppose for today's topic is recursion. The last week it was a exception handling, right? So these are the topics. So the topics will be same. It will not be like outside of the topic, the questions.
All right, perfect.
So does anyone have any other question? Okay, then. So I will see you guys again on Thursday then. Okay. Yeah. So let's end today's meeting. Thank you, everyone. Stay safe, everyone.
Thank you.
Bye.
Yeah. Bye. So I will upload your video lecture very soon. Okay. Whoever didn't participate.